But what's the drawback? If you're stuck with 1/2 base times height, what is the drawback? Look at the triangle in 11A. What's wrong with just doing 1/2 base times height? You don't know the height. So if you're going to rely on 1/2 base times height, then you're going to have to do some trigonometry every time in order to find the height. Now, that isn't hard at all, but luckily, we have a couple of handy little formulas that allow us to find the area of non-right triangles very, very handily. The area of this triangle, and you could drive this easily yourself if you had time. The area of this triangle is, watch this, 1/2, 10, 12, sine 37. That's it. Type it in. That's the area of the triangle. That's a degree measure. So 0.5 times 10 times 12 times sine 37. 36.109. Know what you got? Easy peasy. Now, pay attention to how that information is situated. If you're going to use this formula, then your information has to look like this. Now, it doesn't necessarily have to be here, it could be up here, but it has to be two sides and the included angle. If you have that, you're done. Easy. Now, let's skip down to C for a moment. We'll come back and do B in a second. Actually, no, I don't like that. That's ambiguous. Let's change this to a, let's erase that and change this to a, let's say 52. Let's look at this triangle. Now, can I use this quick idea? Nope, what am I missing? I need a side, right? Don't really care which one, I just need one of them. So, just for fun, let's find side H. Doesn't matter, find any side. Once I have side H, then I can say my area is 1/2 10 H sine 47. Would you agree with that? How are we going to find side H? Law of sines? Because if that's 47 and that's 52, what's this one? 81, check my arithmetic, is that right?
Yeah.
So, sine 81 over 10 equals sine 52 over H. Everybody okay, law of sines? Sine 81 over 10, sine 52 over H. So 10 sine 52 divided by sine 81. Did you get 7.978? But remember, that isn't our answer. We're going to take that times 10 times 1/2 times sine 47. And our area is 29.175. Oh, yeah. Is that right? You okay with that? Okay. Now, what about B? What about B? Well, we're not going to be able to use our simple little formula because we have two sides, but we don't have an angle. So for example, we could say the area is 1/2, 10, 12, sine h, but I'd have to find h. Same thing here, 1/2, 12, 14, sine s. I have to find an angle. Can I find an angle? Absolutely, this would be law of cosines. But, and you can do that. If you want to do that, that makes sense to you, absolutely do it. But there is a shortcut. There is something called Hero's formula, and it's actually Heron's formula, Heron of Alexandria, but it's been kind of abbreviated because he's our hero, to Hero's formula, and it works like this. If you know all three sides of the triangle, and that's the key, you gotta know all three sides. If you know them, you can find the area with this little formula. Now, what is the perimeter of this triangle? 36. The semi-perimeter is 18. These S's stand for semi-perimeter, half the perimeter. The A, B, and C are the side lengths. I know for me they're C, H, and S, but these are the side lengths of the triangle. So, Hero's formula says 18, 18 minus 14, 18 minus 10, and 18 minus 12. All of those things multiply together and square root it. And I got 58.788. Please don't use Hero's formula unless you've got all three sides. Because if you have any rounding off at all, it's just going to get multiplied like crazy in there. But as long as you have all three sides, you can do it in a snap.
Could there ever be where there's all three sides in like one angle?
There could be, but generally speaking, and obviously there's three angles in there, and we can figure out what they are. But usually when information is presented about a triangle, you're given three things.
Okay.
You could be given more. And if I knew this angle,
You could still do.
you could still do Hero, absolutely, but I would do one half side sign because that's just faster. But you can do whatever you want. You could do the laws cosines and find an angle and do one half side side. That'll work. You'll get the same answer. And if we had time, I'd show you. The answer will be the same. We don't have time because we have one more thing to talk about. We work with matrices. Did you do matrices in Algebra 2? You did. Good. And this is going to be a breeze. We're only doing 3 matrix operations. There are zillions of them. You can take a whole class called linear algebra, and it's nothing but studying matrices. But we can't, so we need 3 things. We are going to find the determinant of the matrix. So the determinant of matrix A. The notation we use is the vertical bars. So if you have a matrix, but you see vertical bars, that means find the determinant. You remember how to do this? You did it last year, I'm sure, but do you remember?
Wait, don't one like represent X and the other one?
Oh, now if you're setting up something to use Kramer's rule, absolutely. And when you use Kramer's rule, you're solving with determinant. To evaluate this, it's just going to be a number. It's 1 times 7, 3 times -1, subtracted. Oh boy. Oh boy, be careful. We did the dot product earlier, and it was x times x, y times y added. This is kind of cross multiply and a subtraction. So the determinant here is 10. Find the determinant of B. multiply these two, and subtract them. What do you get? Negative 24. Negative 24. Now, to find the inverse of a matrix, that's what this means. This means find the inverse. The first step is to find the determinant. So what is our determinant? 23. Good job. 3 minus negative 20. 23. Now, you did this last year too. If you did Kramer's rule, I'm sure you did this last year. We're going to find the inverse of this matrix. Look where I'm pointing. These two numbers switch places. So 1, 3. These two numbers change their signs. So this is negative, it becomes positive. It stays there, but it becomes positive. This is positive, it becomes negative. So negatives become positive, positives become negative in these two spots. Then we take each of those and divide by the determinant.
They switch their signs, or
They change.
Or they go to the opposite?
They go to the opposite of what they are.
So if they're both positive,
They both become negative. They have nothing to do with each other. These two do because they literally switch places. And all this has matrix algebra behind it. So if you're really curious, you can Google. Now, this actually is the answer. Usually we can simplify, but nothing simplifies there, so I'm not going to rewrite it. That is your answer. So we simply find the determinant first, then we switch these two, negate these two, and divide. All right, can you try B? Can you see if you can find the determinant of B? Or not the determinant, the inverse, I'm sorry, find the inverse of B. So finding A inverse. What'd you get for your determinant? Determinant is 21. Now take the 3 and the 7, switch them. Take these two and change their signs. 0, of course, is just 0. And then divide everything by 21. This one can reduce. So our inverse is 1/7, 121, 0, and 1/3. There's your inverse. Okay, so in order to do that, you have to remember how to find the determinant. So determinant, multiply, subtract. And then find the inverse, one over the determinant is, and we divide everything by the determinant. These two numbers switch places. These two change. Their signs change. All right, last thing we're going to do is multiply matrices. Remember how to do this from last year? If you guys did matrices, I know you added, multiplied, subtracted. I know you did all that. We're going to multiply these two together. And order matters, guys. Matrix multiplication is not commutative. So AB, this is A times B, is going to give me a different answer than B times A. So make sure you do them in the right order. In order to multiply matrices, the dimensions have to match up in a special way. This is called a 2x2 matrix because it has 2 rows. I believe bleachers and 2 columns. This one is also 2 by 2. Now, they don't have to be the same size to multiply. These two are the same size, they don't have to be. What has to match is these right here. So you can multiply a 2 times 4 and or 2 by 4 and a 4 by 3. Those can be multiplied. A 2 by 4 and a 3 by 4 cannot be multiplied. So rows, columns, rows go sideways just like the bleachers in the gym. Columns go up and down just like the White House. Rows, columns, RC, Roman Catholic, RC, RC, these have to match. Now, if they do match, which ours do, then your answer will be this big. So the insides match. My answer will be a 2 by 2. So it's going to look like this. I'll just set up some blanks. I'm going to fill those numbers in. So my other example, when I had 2 by 4 and a 4 by 3, those can be multiplied and my answer would be a 2 by 3. Now, this guy right here, I'm going to figure out what this number is right here. That number is in row 1, column 1. Would you agree with that? So I'm going to take row 1 of my first matrix and column 1 of my second matrix. Always row, column. I'm going to take these two numbers, 1 and 1, and I'm going to multiply them by these two numbers, 3 and negative 1. So first number of the row times first number of the column, second number of the row times second number of the column. I'm going to multiply them together, each pair, and then add. So that gives me a 2. That number is a 2. Now, how do you think I'm going to do this one? Where is he? Row 1. But now he's in column 2. So your 1 and 1 times your 2 and 5. So that number will be a 7. So 1 times 2, 1 times 5, add them up. All right, do your bottom row. Can you do the bottom row? You're doing the same thing, but now you're using these two numbers. Now you're in the second row. So you're using negative 1 and 2. And you multiply first by 3 negative 1, and then by 2 5. I got negative 5 and 8. Do we need to check any of those? Either one? That looks right. Alright, there's one more. We're not going to get our time for it. I don't think, let me check my schedule. Oh yeah, we do. Yeah, we can do that last one. Then we'll be done. Can these even be multiplied? Our last example here, can these two problems even, or two matrices, even be multiplied? What are the dimensions of A? 2 by 2. And what are the dimensions of B? 2 by 3? They can be multiplied. Remember, these are rows, these are rows, these are columns. So we have 2 rows, 2 columns, 2 rows, 3 columns. And my answer will be a 2 by 3. All right, I'll do the first one just in case there's anybody out there it's a little bit lost. This, I'm going to find this number. He is in the first row in the first column. So I'm going to take the 2 numbers in the first row and multiply them by the corresponding numbers in the first column. So first row, first column. So that number should be a 6. All right, you fill in the rest. They match those. All right. Well, here's the practice. So here's what we're going to do. Here's the last page of practice problem. You already have the first one. This is a lot. Do what you can, because the more you get done, the more better questions you can ask, and the more helpful it will be tomorrow. But we need to do 7D and E. We skipped those last time. 7D and E. And then as much as of 10 to 14 as you can, preferably all of it. I did it this morning, and it would take that long, but I did also. So 7D and E. And then 10 to 14 as much as you can, hope and hope. Tomorrow when you come in, I will ask you what kind of questions you have. We'll work through the extra problems of whatever we need to do. We have an hour and a half tomorrow. And then we'll take our little assessment.
As we come to the end of the day, let us pray and holy call and keep our faith. In the name of the Father, Son, and Holy Spirit. Hail the cross, our only hope. With her leading, we shall not tire. Our Lady of the Hill, pray for us. In the name of the Father, Son, and Holy Spirit. Amen. Classes have ended. Go in peace.
All right. Everybody can go. See you tomorrow. Have a good day. I thought we still had stuff. Oh, we have office hours. You can stay and work on your stuff if you want. We have office hours for 2 hours. Oh. Yeah. Oh, somebody's got gum on the floor.